our YouTube channel of the series of basic process engineering calculations. In this session, we will focus on calculation or how to calculate the maximum pressure due to surge pressure scenario. So first we will understood what is meant by the pressure surge and how it happens. The pressure surge occurs due to rapid deceleration of the fluid. That case occurs due to the sudden closing of the valves or the pump stops suddenly. The momentum of the moving fluid gets converted into the acoustic or a pressure wave, and that could result in the rise in pressure exponentially within a short period of times, means within a fraction of seconds, and that could lead to the potential damage that overpressure can cause the bursting of pipes, leakage, or damage the fitting or supports. And if any harmful or hazardous chemical transferring line, then that having other consequences as well, as that may be a health hazard or environmental hazard. So we will see how to calculate the max pressure rise, and based on that, if that falls in the case of high surge pressure or high pressure, then the design pressure of connected system, or that may be a piping. So the necessary mitigation measure or necessary preventive actions to be taken based on that. So that is the latter part, but first we have to come to that point that what would be the max pressure due to sudden change in velocity due to rapid closing of walls and all these things. So first we will see how to calculate the max pressure due to surge case using simple Excel template here. So I would explain you how to calculate using that surge pressure. Okay, and to calculate that surge pressure we need some data, and we will input that data: diameter of pipe, then we required density of the material which is we going to transfer from the any of the source to the receiver. Then we need the length of the piping, because that directly contribute to the pressure rise or pressure uh, directly proportional to the pressure. So then again we need volumetric flow rate of material. What would be the material? That whatever it may be a material. So we need the what is the actual volumetric flow rate. Then also we need which rating of piping is installed, pressure rating of piping, and fittings, whether it is PN10, PN60, whatever it may be. So we will first note down whatever the things we required, and based on that we take one simple example how to, and I will explain how to calculate based on that parameters. Okay, then we required upstream pressure, then based on that we calculate the further uh, calculations like cross section and all these things. So first we will input the data. We will consider 50 mm line size. Then we assume just density of random material, that may be 900 or 870, 860, or that maybe as per the whatever chemical or material you are transferring, you can consider accordingly. Okay, I'll just show you with the random numbers. We consider length 90 meters, 950 meters. Then volumetric flow rate, we consider that this is the solvent, so we consider on lower velocity, and based on that we have assumed just 10 meter cube per hour of volumetric flow rate. Then we have to enter the whatever the pressure rating used in the system, that may be derate over a certain period of time, but we will consider here, and I have put it down the upstream pressure that you will get, like whatever, if you are transferring material from the tank farm or any source to the receiver, and you have a control wall or on off wall at nearest point of receiver. Okay, so what would be the pressure at the nearest point of receiving wall, that we need to add here with excluding the pressure drop across the piping. Okay, if you are supposed to transferring material with the pump having head 40 meters, and you have to calculate the uh, pressure drop across the piping, which I have already explained in earlier session, and I will put its link in this video also, so that you can refer that to calculate the pressure drop across the piping, and whatever may be the delta between the actual head minus pressure drop, you can write it here as upstream pressure in bar gauge. Okay, then we have to enter the closing time of wall, because that's the main uh, parameter required to calculate the surge pressure. Okay, if you have uh, actuated wall with size up to 80 mm or 3 inch, then it's having the response time less than 3 seconds. Okay, and that is directly relevant to the pressure surge scenario. If to avoid the pressure surge scenario, you have to sometimes uh, go with the higher size walls with the, so that you will get the more closing time than the 3 seconds. But here we have considered the 50 line size, hence I am simply writing down the standard closing time as per the standard on of wall supplier. Okay, so based on this data, we can calculate the calculate the surface of the pipe cross section. Okay, cross section, which is simply pi by 4 into d square. Okay, first pi by 4 into d square. Okay, 1000, that we have converted into the meter. Okay, so we'll get the cross section area in meter square. Then we have to calculate the change in velocity, because once we have closed the one of wall, that results in the change in flow velocity. Okay, and that can be calculated by flow rate divided by the cross section. Okay, area, that's in meter per second. Okay, now we got the upstream, the change in flow velocity and the cross section. Based on this, we can use the uh, Joukowsky equation, and with reference to that, we can calculate pressure in case of pressure increase according to Joukowsky. Okay, Joukowsky equation that is calculated based on the 2 into density to rho into the change in flow into the length of pipe, whatever you have considered, divide by closing time into 10 to the power minus 5. So you you will get the pressure into bar gauge. Okay, so now you got the pressure increase by Joukowsky, then the max pressure due to pressure surge. Okay, that's equals to the pressure increase as per the Joukowsky equation plus the upstream pressure. So okay, so that's within our limits. Okay, as we have the piping and all the fittings are rated for the 10 bar gauge, and the surge pressure calculated is less than that. So in this case the system is inherent safe. Okay, now I'll just show simply how it affects, or we can go beyond the 10 bar gauge design pressure or piping pressure rating. So we just simply change the flow rates, it's directly goes beyond the max design pressure. Okay, so by that means the pressure surge is proportional to the flow rates as well as the piping length. Okay, I'll just put it down 10 meter cube so it comes to the original calculated pressure rating. Then we increase the length, so it as we increase the length the surge pressure goes on the upper side. Basically Joukowsky equation provides a good estimate. The actual pressure surge can be influenced by the various factors such as piping material, fluid properties, or system geometry, elevation in the piping and receivers, and to calculate detailed hydraulic transient analysis you can use computational method, so that gives you a accurate prediction in a complex system. And this the calculation I have explained here you can use for the normal routine operations or simple material transfer systems from source to receiver. Okay, hope you got the clarity about how to calculate the pressure surge, max pressure due to the pressure surge scenario using the Excel. If still you have any doubts, you can drop me a message or comments. There is another way to calculate is surge pressure is a computational method, and also there is one method from which you need some another data like modulus of elasticity and all these parameters. And in actual practical scenario this data is difficult to get in the chemical industries to calculate a precise calculation using that also. So that's why I preferred this method and hope this would be helpful to you all, and thank you for watching. Please subscribe our channel if you are new to this for such a new basic process engineering related calculations based on the routine practical experiences. Thank you for now.